Now we're going to look at rational and irrational numbers and then some polynomial operations. So to begin with, rational numbers is a set of numbers expressed in the form of a fraction, a over b, where a and b are integers and b cannot be 0. So basically any number that can be written as a fraction is a rational number. So for example, 4 is a rational number. Okay, so is 1/2. So is 4/3. Right? Anything that can be written as a fraction is a rational number. Okay, now 4 is technically 4 over 1. Okay, so it is also written as a fraction. So any of those numbers is a rational number. Irrational numbers are numbers that cannot be written as a fraction. Okay, so they cannot be expressed as terminating or repeating decimals. Okay, now terminating means it's one that ends, so like 1.2. Right, or repeating like 1.333, right, 1.3 repeating. Okay, those are rational numbers because 1.2 is the same as 6/5, and 1.3 is the same as 4/3. So those are examples of rational numbers. Right? Irrational means that it can't be expressed like that. So for example, an irrational number could be pi. Okay, remember pi starts as 3.14159, blah, 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 blah. It goes on and on forever. That is an irrational number. I cannot write that as a decimal that stops or one that repeats. It just keeps changing. Okay, some other examples are the square root of 2. Okay, I can't take the square root of 2 and get a whole number, right? Like 4 or 9, right? They work out to be a perfect square. The square root of 2 is like 1.4 and so on. So it's an irrational number because the decimal does not stop. It's a never-ending decimal. So some properties with rational and irrational numbers. The sum or product of two rational numbers is a rational number. Okay, so for example, if I were to add 3 1/2, I would get 3 1/2. Okay, that's a rational number. Or if I were to multiply 4 1/2, okay, that's multiplying two rational numbers, my answer is 2, also a rational number. Also, the sum of a rational number and irrational number is irrational. Right? So if I were to add 3 and pi, right? 3 plus 3.14159, blah, 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 on and on, is going to give me 6.1415, blah, 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 and so on. Okay, so that irrational number kind of messes up for making it become a rational. All right? And lastly, the product of a non-zero rational number and an irrational number is irrational. Just like before, the irrational part here kind of messes it up, so does it here. All right, this irrational number here messes it up. So if I were to do 2 times pi, right, 2 is rational, pi is irrational, that's going to give me 6.28 and so on, right, 3.14 times 2. Okay, so it's going to be irrational. Right, now non-zero, because 0 times anything is 0. Okay, so it's got to be a non-zero rational number in order for this to hold true. Polynomial operations. So we got adding, subtracting, and multiplying. Okay, so whenever we add or subtract, we're going to do one thing where we have to combine like terms. Now remember, like terms is same base, same exponent. Okay, same base, same exponent. Alright, same base, same exponent. So for here, alright, I don't need my parentheses because I'm adding. Alright, so I don't need them, but I've got 3x squared and 2x squared. Got 3x and negative 3x, and I've got a negative 2 and a positive 3. Those are my like terms. Alright, generally speaking, you go from biggest exponent and then you go in descending order. So biggest to smallest. So my biggest is squared. So I got 3x squared plus 2x squared, which gives me 5x squared, positive 3x and negative 3x is 0, so these end up canceling out. And then negative 2 and positive 3 is positive 1. So that simplifies to 5x squared plus 1. Subtracting the parentheses are important because I'm not just subtracting 2x squared. I'm subtracting this whole quantity. Alright, so I have to distribute this negative. Now remember, out front, if nothing's written, that's an automatic 1. So I'm going to distribute a negative 1 to that entire parentheses. So I'm going to bring my first one down. I got 2x cubed minus 3x plus 1. Negative 1 times 2x squared. Just change it to a negative. This positive changes to a negative, and this negative changes to a positive. Now I'm going to do like I did before and combine like terms. I don't have anything to go with 2x cubed, so I'm going to go ahead and bring it down. That's my biggest exponent. Okay, my next is 2x squared. I don't have anything to go with that, so I'm going to bring down 2x squared, a negative 2x squared. Then I've got negative 3x and a negative 2x. Gives me negative 5x. And I've got a positive 1 and a positive 1. Gives me positive 2. Just combining my like terms. Multiplying. Okay, we've got two ways that we multiply, right? One is FOIL and one is a box. So we're going to do both for both of these. Whichever one you prefer, that's the only one you need to write down. I don't want you to be able to do both of these as much as I want you to be able to do one every single time and do it perfectly. Okay, I want you to become an expert on one of those methods. Okay, so we've got FOIL and box. So the FOIL method. First, outer, inner, last. So first terms, so 3x times 3x is 9x squared. Don't forget your squared. Outer, 3x times 3, 9x. Inner, negative 2 times 3x, negative 6x. And last, negative 2 times 3, negative 6. My like terms are right in the middle. I've got 9x and negative 6x, which gives me 3x. So I've got 9x squared plus 3x minus 6. The other method is the box, right? So for this example, I'm multiplying a binomial and a binomial, which means I'm going to have a 2 by 2 box. And it doesn't matter which one I put across the top and the side. So I've got 3x and a negative 2, 3x and a positive 3. Now I just multiply to find the area of each box. Right? So 3x times 3x, 9x squared. 3x times negative 2 is negative 6x. 3 times 3x is 9x. And 3 times negative 2 is negative 6. Okay? I have some like terms, and they are diagonal. So now I'm just going to add everything up. So I've got my 9x squared. 9x and negative 6x is positive 3x, and then my negative 6, which agrees with what we just found. The next one's a little different. Now I've got a binomial, because there's 2 terms in the first parentheses, and a trinomial, because there's 3 terms in the second. My steps don't change. Okay, I can't necessarily do first, outer, inner, last exactly, but I'm still going to take every term in this first parentheses and multiply it by every term in the second. Alright, so if you're doing FOIL, I'm going to do 2x times 2x cubed, which is 4x to the 4th. Right, I got 1x here, 3x's here, gives me 4x's. Then I got to do 2x times negative 3x, which is negative 6x squared. And then 2x times 1, which is just 2x. And then I got to do the same thing with negative 1. Negative 1 times 2x cubed is negative 2x cubed. Negative 1 times negative 3x is a positive 3x. And negative 1 times positive 1 is negative 1. Now I've got to look for my like terms. My biggest exponent is 4x to the 4th. Nothing goes with it. Right? Then I've got a 2x cubed over here. Okay, a negative 2x cubed. Right? Then I've got a negative 6x squared. And then I've got 2x and 3x to give me 5x, and then I've got minus 1. So the only like terms I had in that whole thing were just the 2x and the 3x, and that's okay. Alright, so that's how we do it by the FOIL method, or the similar method. The box. Up here, I had a 2 by 2 because I had a binomial times a binomial. Now I've got a binomial times a trinomial, so I'm going to have a 2 by 3. And it doesn't matter where you put your 2 and where you put your 3, but you just need 3 going one way, 2 going the other. So I'll put mine this way. Now I do have to put mine on specific sides. The 2x minus 1 has to go down the side because that's where my 2 boxes are. Alright, and then 2x cubed minus 3x plus 1 across the top because that's where my 3 boxes are. Same thing I multiply. 2x times 2x cubed, 4x to the 4th. 2x and negative 3x, negative 6x squared. 2x and 1, 2x. Negative 1 and 2x cubed is negative 2x cubed. Negative 1, negative 3x, positive 3x, negative 1 and positive 1, negative 1. Okay? Now, you could have like terms diagonally like we did up here, but that's not always the case. So look and see what we have. I've got a 4x to the 4th. I got negative 2x cubed and negative 6x squared. Those are not like terms. Right? And then I got 3x and 2x. Those are like terms. And then negative 1. Now I'm going to pull everything out. So start with my highest exponent. 4x to the 4th. Then negative 2x cubed. Negative 6x squared. 3x and 2x give me 5x. And then minus 1. Which is what we found with the FOIL method. Again, either way works. I just want you to pick one and stick with it. Become an expert with it. It's going to be really handy when it comes time to factor.